way, quick drink.
Yes. Okay, I gave you this chart. The chart lays out everything. Okay, so there's two different types of functions that we worked with. We worked with exponential, which is what we talked about yesterday, and we worked with this log function called log. Okay, we worked with both of them, but we worked more with the exponential form. So when we went left and right, remember that's your h value in green here. So that h value was the left or right. That k value was up or down. The number all the way out in front tells you if you're reflecting or not. Okay, so those pieces correlate with that chart. So let's talk about 1. Can you tell me what is going on in the situation? Am I moving up, down, left, right, reflecting? What's going on?
Right 4.
I'm going right 4. I'm going to highlight the same color. Look, this 4 is up here. That's that 4. If you look, when it's negative, it shifts right. Okay, that's just, remember it was at the opposite usually. So this is going to be right 4. And what does in purple the 3 mean?
Up 3.
Up 3. And you're done. Okay, so this part all the way at the end is going to be the up or down. If it's by the x, it moves left or right because that's what the x-axis is. Your phone's away. Okay, piece by piece. The number all the way out in front means what all the time?
Reflect.
Reflect over what?
X.
Over x-axis. Okay, now this one's tricky, I feel. Some people get these ones wrong just because of this little piece. What does this negative 3 represent?
Down 3.
Down 3. Very good. I'm glad that you said down 3. The reason why it's down 3, because look at your problem up here. In order for it to be moving right 3, which a lot of people think it is, it must be in parentheses because it's grouped with the x. And on the outside is going to mean down 3. And we're done there. Okay, I want you to take a second and see if you can do 3. Take a second and see if you can do 3. If you can do 3, because it's the hardest one, you're golden. You're set. Okay, so give it a try. And the chart's right above if you're getting stuck. Refer to it. Remember, every piece that's different you need to talk about. The 1/4 you need to talk about. The +1 you need to talk about. And the -7 you need to talk about. What does the 1/4 mean in front? Compress. By 1/4. What does the green piece mean?
Left.
Left 1.
Very good. Left 1. And then in purple, other than Micah? Down 7. Very good. You've been doing that, I think, since freshman year. It's just different functions.
For compression, do we have to put the fraction or can we just put the number?
It will say on the final, like, compressed by 1/4. Or it'll say stretched by 2. Okay, so
What would be multiple choice?
final exams are always all multiple choice, yes.
Nice.
Except for sometimes English, I think. Or Spanish. You could do a project. Okay, cool. So that one's pretty straightforward. That means, again, there are 2 questions on your final, 25 and 26, that apply to transformations. So make sure you know them. All right here. There are 3 questions about graphs. On all of the graphing questions, I gave you the graph on the test. And if you look at your packet, you'll see that, which is a benefit for you because usually people they'll make you type it in. So in the future, they will make you type it into y =. Hopefully you know how to do that because I feel like this year you've been so much better at it. But just for the sake of notes and for the final in this class, I gave you the picture. So here's the graph of 3x.
Growth.
It is going to be growth. Thank you. Because it's growing up. It's increasing. What transformations are being done? None. Because that's your parent function. That's called a parent function. In this situation, nothing's happening. Now, if there was a 3 right here, that would be stretching. So a lot of people think it'd be stretching. You won't have to know that part. Usually if I ask you for transformations, there are some, but in this situation, there is none. Okay, domain. See if you remember this from way back. Yep. What'd you say?
Negative infinity.
Very good. So your domain in red is negative infinity to positive infinity. The range is usually where we get confused. Range, remember, in blue is bottom to top. And if I write out my infinity signs and I go bottom to top, I don't start happening until right here. I don't start having a function until this piece. Where does that start? What y value? 0. So I start at 0 and I go where?
Infinity.
To positive infinity. Very good. And I'm going to put a little bracket there. Oh, actually, no, I'm not. It's not included. Right. Whoopsies. Okay. This is going back to like at the beginning of the semester, but we did it last semester too. Does anyone remember what an asymptote is? Because that's something that y equals something, yeah. But what is it? Yeah.
No, mine.
Okay, go ahead.
It's like the wall that you can't pass through.
Exactly. In a way, metaphorically. Do you have a better mathematical explanation? Something else? So it's like a wall. Go ahead.
Is it when it like curves and it's like the thing right there and it curves?
So yeah, it does. You mean like curve? Like this?
Like, you know, I don't know how to explain it, but I kind of remember where I cannot. Okay, so there's like, the asymptote is where when it curves, right?
Where it curves?
Yeah.
That's it. Yeah.
For real?
For real.
Okay.
Okay? So you remembered something. That's awesome. So your asymptote, I'm going to draw it in. I'll put like a little dotted line maybe in blue. This is your asymptote. And what y value is it at? Where does a function start? That we just talked about for the range. What number? 0. So your asymptote's at y equals 0. Remember way back when I was like, the asymptote and the range go together in exponential functions. I start at 0. That means there's a wall, like Micah said. There's a wall that the function never goes past. Look, there's nothing here. Okay, it's like a wall. It means it does not exist in the negatives in this situation. Where does it cross the y-axis? Where's the y-intercept?
1.
Good, and how do you write that? When I say, what's the y-intercept, what would you say? 0, 1. Very good, guys. You guys are killing it. That means I taught you something. That makes me happy. Okay, here's the fun part. I will ask you for end behavior, but it will be multiple choice. So you'll be able to look at it. Okay, remember what end behavior was. End behavior just represents the domain and range. Phones. Your domain is always here because it's your x's, and your range is always here. So we always look at our range. These two numbers, or infinity, should be in here. You just got to figure out where they go. Because this spot is always your range. So whatever your range is, will go in this spot. So, as x, don't write this down. I'm just going to show you visually. I'm going to unhighlight everything. Okay, here's x. I'm going to rewrite these out. Negative infinity, positive. In purple, as x is getting towards negative infinity. Here's my purple. In blue, where is the function approaching? Not 1. 0. So remember, I kind of just talked about this a little bit, and it's okay if you forgot. It's always going to be your range, so it better be one of these. You just got to figure out which one it is. So it has to be 0. It can't be 1. It's got to be one of these. And then the other one's going to be what? Based off your range. What's the other part of the infinity? And here's why. In green, as x is getting bigger, 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 the function in yellow is going up. It's going towards positive infinity. Increasing. And it's increase. Very good. Increase. Does it always increase? Yeah. And it increases on the interval negative infinity to positive infinity. That's an awful infinity sign. That just means that it's always increasing. That's what that all real numbers is. It means it's always increasing. All right, let's do another one like that. We only got 2 more left, and then you're done. And then until Monday. Because we're going to take a day tomorrow. Okay, here we go. Am I going to grow or decay?
Growth.
Growth. Boom. Oopsies. Okay, your transformations. Here we go. What I'm going to do is I'm going to highlight. I'm going to box this. Why don't you guys box it too? This piece right here is your parent function. Parent. Just for the sake of studying with me in your study session. That's your parent function. You can't include the 2 anywhere else. The 2 is part of the parent. You can't say it's stretching by 2. It's part of the function. But I can talk about the 1/3. What's going on?
Compress.
Compress. Compress by 1/3. Okay, now in green, what does this +1 mean?
Left one.
Left 1. And give everyone a second to think. What does this -3 at the end mean? Good, down 3. I'm just getting you practice with that. On the final, you don't have to do all this work. I'm just going to ask you one piece, and that's why we have to practice it all. Because I'm going to ask you, like, what's the range? I'm not going to ask you every single piece about it, but I'm going to ask you what the range is. Or I'll ask you what the domain is. Okay, so you'll have to just, I'm just trying to practice all of them so that you get used to it. Okay, the domain is left to right. What's going on here? Left to right. Very good. It forever goes left and it forever goes right.
Just put our numbers too.
You can, but it's gonna be in interval form. That's called interval form, and that's negative infinity to positive, yes. But it is all real numbers. Now your range is bottom to top. Where do I start?
-3.
Very good, -3, because that's my asymptote. My asymptote is -3, which means that's where I'm starting. And where do I go to?
Infinity.
I go to positive infinity. Basically what range means is like, where do you see the graph? Where is it located? It's located from -3 on, going up forever. Your y-intercept, don't worry about that. I don't care about this one, this y-intercept. Now again, your domain in blue is always represented here in your end behavior. That means that my range in purple is going to be represented here. So I have -3 and infinity. We just have to figure out what spot it goes. Here we go in pink. As x gets smaller, where is the function approaching in pink? -3. Remember, you only have 2 options. You only have 2 options. So what's the other one? Positive infinity. And here's why. Look, get a bigger marker. It's going up right here to positive infinity. Okay? Your end behavior is just telling you, hey, what's my domain and range? That's what that means. Am I always increasing or always decreasing? Increase. And I just represent that by negative infinity to positive. Okay, so that's like number 31 on your exam. So again, on the exam, I'm not going to say, hey, give me all of this. I'm going to say, hey, what's the range of this graph? And that's it. Okay, I'm not going to ask you to do all of it, but we got to practice all of it because you don't know what piece it's going to be. Now, another thing I'm going to point out in blue, this piece always helps you with your range. Always. Going down 3 is what helps you. Last one. Now look, this one has 4 questions. Like it. 4. So it's probably something that you want to pay attention to. 4 questions out of 35 is a lot of questions for one thing that we're going over. So if you were to wake up at all today, it would be right now. Okay? So this is called a log function, and we talked about it. It's the inverse of an exponential, which means just everything flips. If you remember what an inverse is, all the x and all the y's flip. Okay? So am I growing or decaying?
Growing.
So go left to right. It's okay. It looks like it's going down, but when you go left to right, it's growing.
Oh.
Okay? Actually, you know what? That's a really bad question. Cross it off. I mean, you can't even grow or decay in log functions. That was my bad. I should have just crossed that out. But if you were going left to right, it looks like it's growing, but you're not growing on forever, so it actually is decaying. You're right, it is decaying. But just, it needs to be flipped. It's a very weird question. It's a log function. Okay, transformations though. I am inside the parentheses. So that means I'm doing what? So if it wasn't inside the parentheses, I'd say yes. But I'm going left 1 because it's inside the parentheses. If it was like this, if I were to take my eraser and I were to like white that out, then it would be going up 1. But because it's in the parentheses, it's going left. And look, it looks like it went left. Usually we always start like normally for a log, it looks like this. So you're going to be going left, okay? Again, these graphs are given to you. Your domain. Now, inverses of exponentials, your x and y is changed. So let's just talk about this so that you mathematically have an understanding. Your domain of all exponentials are always all real numbers. But if your domain is all real numbers here, what's going to happen in the inverse function? Do you remember? That's a really hard question, but I want to know if you can get it. If my domain is all real numbers for exponential functions, because logs are the inverse,
You flip it.
I do flip it. So what does that mean?
Positive infinity, negative infinity.
It's still going to be all real numbers, but where is it going to be all real numbers now? Not the domain,
The range.
the range. Okay, and I'll explain that. And we'll look at the graph, but just know kind of what math really means. Inverse functions are their opposite, so we should get all real numbers for the range. Because look, your domain, when you go left to right, do you see, if I zoom in pink, that it just like stops here? It doesn't keep going left. It stops. Like it doesn't go past that part. Hold on, it looks weird because you can't really see it. But right here, that's actually your asymptote. And let's talk about that before we do anything. I like to talk about my asymptote first. We're no longer y. Inverses are now going to be what? X. So my asymptote is going to be x equals something. That means that it's always going to be this number. What number is it?
Negative.
-1. And where did that come from? Oh, look. Because we moved left 1. There's a reason why math all goes together. We moved left 1, so it makes sense that our asymptote is at -1. Okay, so because of that, we can talk about our domain. Look, I have no function, no function, no function. I start here and I go to there. What do you think my domain is? Very good. I always start at my asymptote and go on to some infinity. It just depends on which one. Okay, my range, what do we think it's going to be? We just talked about that. All real numbers. Because look, it's forever going down, and it's forever going up. It just will take a while to go up forever. We're almost done, guys. I'm going to fix something instead. Meh. I'm going to fix something instead. Because there is a question like this on your exam, but I wrote it wrong. I forgot to change it. So I need to change this to to -1 instead of infinity. It needs to be a -1. So I apologize. That needs to be a -1 instead, and it needs to have a plus sign. So even if you want to just completely cross this part out and write the limit as x goes to -1 from the right side, so it's a plus sign. So this is way back when. I'm sorry, you probably can't even see that. The limit as x goes to -1 with a plus sign. Because if there's a negative, it means the left. And I'll explain that in a second. Oop, goodbye. So just rewrite that. That's a notation error on my part. I wrote it wrong. Because it was way too late when I was making it for you. Let me actually just white it out. The limit as x goes to -1 from the left. Okay. So, whenever there is a plus sign, and I'm going to make a note of this because you need to know this, and I'll put it like a little arrow. Oh, stupid thing. Okay, well, you guys have it here. The plus sign means that we're coming in from the left, and the minus sign means I'm coming in from, wait, hold on, flip it. See, when I get messed up, I get messed up forever. Well, the plus sign means I'm coming in from the right, and the minus means from the left. And that makes sense, right? The negatives are on the left side, and the positives are on the right. That makes sense. So now I'll explain it. Sorry about all that confusion. So here we go. Let's talk about this. You guys are actually really good at this. As x is going towards -1, see how x is starting to go there? In blue, I'm going to zoom in so you can actually see it. I would definitely just watch this and not write right now. As x is going into -1 from the left, where is it going?
Down, just down.
Down to where?
Negative.
-infinity.
Bikini Bottom.
What'd you say? To bikini bottom. Very good. Okay, now again, visualize this with me. As x is going to positive, here it is, as x is going to positive infinity, where is it going to go? In pink. Where is it going? Slowly. What'd you say? Yeah, to infinity. Very good. And we're done. So if you notice though, here's what I want to make a note for you. For log functions, remember your range is always represented here. So when you guys have the multiple choice, you can cancel something out because it should look like your range. And then here, look, this, oopsies, this -1 is going to be right here and that positive's there. Okay, that's how those work. They talk about your domain and range. Am I increasing or decreasing left to right?
Increasing.
Increasing. So it's increasing, but we can't talk about growth and decay because it's not exponential. So the only time it's going to be growing or decaying is if it's exponential. So that's why we had to cross that one out. Okay, you are done with me. You have a log time. You have all of those questions. If you now need to reference something,